Hi everyone, on to number 7b from applications involving right triangles. So if you'll remember from A, we have two people on level ground sighting a balloon from two different points. What's different in part A, the 2 points are still 80.4 meters apart, but the balloon is on a straight line between the two. So if we have A on one side and B on the other, the balloon is somewhere in the middle, and we're trying to determine how high the balloon is in this situation. Okay, so this entire distance is 80.4 meters. And we have, let me think about this, a 12-degree angle and an 18-degree angle. The 12-degree angle is going to be this smaller one, and the 18-degree angle is this bigger one. So this is point B, and this is point A. Okay, so looking at this, I again see two nice right triangles. And just like before, slightly different, but really similar trouble. So again, if you're comfortable, this would be a great one for you to try and crunch through on your own, and then you can come back and watch the video to double check yourself. Okay, so there's my two right triangles, and what's trouble here is that I do have the side length for the entire big triangle, but I don't have a single side length for either of those littler right triangles that I actually know how to work with. So we're going to do the same thing that we did before. We're going to say, what would be nice to know? And the answer is the base of either one of those. It doesn't matter which one, so I'm just going to say it's the yellow one. I wish that I knew that. If the base of this triangle is x, then the base of the purple triangle is 80.4 minus x. So still, if we know one of the side lengths, one of the bases, we know both. And then from here it continues very similarly. So great algebra practice for you to try this one out. If I look at tangent of 18 degrees, I'm going to get h over x, opposite over adjacent. And thinking ahead to what I did last time, I think I'm going to go ahead and solve that for h. Okay, so now I know that h is equal to x times the tangent of 18 degrees. From the other triangle, so that's triangle 1, here's triangle 2, I know that tangent of 12 degrees is equal to h over 80.4 minus x. Okay, and then here comes the substitution. H is the same as x times the tangent of 18 degrees. So my equation turns into a single equation with variable x, but once again, it's slightly messy. So let's work through the solve. I'm going to go ahead and clear fractions first. So I have the tangent of 12 degrees multiplied by 80.4 minus x, and that will get the 80.4 minus x canceled out of the bottom here. Multiply both sides by it. And just leave me with the x tangent 18 degrees. I now have x freed from fractions but stuck in parentheses, so I'm going to distribute. I have an 80.4 tangent 12 degrees minus x tangent 12 degrees equal to x tangent 18 degrees. Okay, so let's see. X is no longer stuck in fractions or parentheses. The next issue for me is that they are on opposite sides of the equation, which I don't like. So I'm going to add the x tangent 12 degrees to both sides, which will leave the 80.4 tangent 12 degrees where it is. It will leave the x tangent 18 degrees where it is. And I'll have a plus x tangent 12 degrees on the end. Got x's on one side. The next step is, how do I get from two different x's down to one? And since these aren't nice constants to add together, the answer is you factor out an x. And I've done nothing to the left-hand side. Okay, and then the final step is going to be to divide. So I'm going to end up with x equal to 80.4 tangent 12 degrees divided by tangent 18 degrees plus tangent 12 degrees. And then this is just a calculator question. Let's see if I still have. Yeah, okay, so this is from the previous example, and the only difference is that there's a plus on the bottom. So I get, where'd my pen go? That x is roughly 31 point, so 80 meters. So if I look back up at my picture, remember, it's fine that we got x, but what we really want is h. So I'm going to go back to my equation number 1, and I'm going to say h is equal to x, which is that 31.80, times the tangent of 18 degrees. So I'm going to take my answer multiplied by the tangent of 18 degrees, and I get about 10.33 meters. All right, and makes sense if you watch the last one. The last one we were almost 50 meters high, but now that we forced the balloon into the middle of these 2 points, it's going to, this 80.4 being the distance between, forces these two to be fairly close together, and the balloon can't be very high based on that. So, seems like an okay answer. Thanks for watching.